Welcome back, everybody, to the second half of our afternoon session. We're going to get right into it here with a presentation from Orbit's Edge.
I am Sylvia France, the president. We are building a specialized satellite that will be able to place edge computing and storage in orbit, providing thousands of times more processing and storage than ever done before. But before we go into the details, let's frame the problem and why this kind of solution is needed in space. Let's say you want to watch a show on Netflix. If your bandwidth is not fast enough or unavailable because weather impacts your dish, you can't watch your shows. Imagine how upset you'd get. That's what's going on today with commercial satellites. The good news is service providers have continuously upgraded home data services. These upgrades include network, storage, and processing, providing us Netflix at our fingertips. It has also opened up new opportunities to create content, revolutionizing our TV experience. For commercial satellites today, we have limited communications in orbit, limited processing, and practically no storage. This has to be fixed and is exactly what Orbit's Edge plans to do. Let me introduce to you Bentley Radcliffe, one of our co-founders. He has been a pioneer in the cloud and edge computing industry. Bentley, can you share why we think this approach is right?
Thank you, Sylvia. I like the television analogy and would like to add one additional point. When you click on Netflix, it is not just internet bandwidth. When the logo comes up, a computer is validating your credentials. It has to find your data in storage, then process and provide you a custom menu. When you stream the video, the computers move the video to a server that is close to you, dramatically improving performance. This is what is called edge processing, and exactly what we are going to do in space. Edge computing, also known as MEC, or multi-access edge computing, is one of the fastest growing sectors and delivers high-performance computing and storage and communications right where the data is created. According to McKinsey report, edge computing represents a potential value of $215 billion in hardware by 2025. Orbit's Edge, in association with our partners, is delivering edge computing for space as a service. Ross, can you provide a deeper dive into the technology?
Sure. CPUs used in space must be radiation hardened, and that process takes many years of development, and the result is that each chip uses technology that's at least 5 years out of date and has only the performance of a first-generation iPhone. Also, chips can cost as much as $200,000. A typical Earth-developed edge computer CPU is 20,000 times more powerful. Orbit's Edge is taking a different approach to solving the radiation problem. We're producing a frame that will protect ordinary Earth equipment from the harsh space environment instead of building custom technology. Our goal is to take the custom out of the satellite. We intend to launch an initial constellation of 30 satellites into LEO in 2024, what we call an edge above the clouds, each containing 5,000 of these vastly more powerful industry standard CPUs delivered in a zero-touch, zero-maintenance model. The constellation is designed so that each satellite features a full 42U rack of high-performance computing equipment that consumes up to 15,000 watts. A large solar array and battery pack allows the system to operate at full performance continuously, whether the satellite is in sunshine or in the shadow of the Earth. The equipment inside is actively cooled to optimal operating temperatures, and the heat the systems generate is dissipated into space through large radiators. And thanks to an extremely effective radiation shield, the internal computers will actually experience less radiation than if they were operating on the surface of the Earth. Our shield will dependably stop particles with charges up to 400 megaelectron volts, and this is an important feature for future quantum computing needs. While computers will continue to improve over the next few years, if we just use today's technologies, each satellite would feature 5,000 processors, 70 terabytes of memory, and 12 petabytes of storage. High-performance communications will allow Orbit's Edge constellation to be used as a relay network through the use of phased arrays for radio, together with a dozen laser communication systems for both satellite to satellite and also satellite to ground. And we intend to seamlessly interface orbiting communication networks such as NASA's TDRS, DoD's MILSATCOM, and SpaceX's Starlink. NASA missions currently produce over 2 terabytes of data every single day, yet only a fraction of this total can be transmitted down to Earth, because global downlink bandwidth is a severe bottleneck. Even with new communications networks such as Starlink, the ever-increasing amounts of data produced by NASA, other agencies, and commercial customers will far exceed the capabilities to transmit it all down. But if you could have inexpensive and plentiful computing power and storage that we just described available in space, the option to process the data up there becomes feasible. The most obvious example is to examine images of Earth observation satellites, and those that contain nothing useful, perhaps filled with clouds or empty ocean, can quickly be sifted from the valuable data that needs to be transmitted down to Earth. Security is also massively improved with increased computing performance. With only iPhone 1 levels of performance on the current satellites, the ability to compress and encrypt data is severely limited, and the satellites themselves cannot implement firewalls or other modern security measures, so they're vulnerable to many forms of cyber threat. If the satellites could utilize a network between them and the ground to provide those security capabilities, everyone's assets become far less vulnerable.
Thank you, Ross. Now let me tell you why this matters and the value it provides to our customers. The Orbit's Edge sat frame constellation will streamline satellite operations and be able to consolidate, analyze, and compress data in orbit, allowing satellite providers the ability to make better use of the spectrum, avoid bandwidth constraints, and send only the relevant data back to Earth. This translates to dramatically lower cost and more timely use of data. It will leverage artificial intelligence at the source, allowing for faster decision-making and response for manufacturers, autonomous mining, new chemical composition, and research. This translates to faster ROI and significant market share gains. In NASA's words, it becomes an enabler for small sats and CubeSats that won't have to deploy extensive communications, processing, and storage by offloading to the Orbit's Edge satellite. This translates to lower cost and better returns on the mission. No longer will the massive amounts of data generated in space need to be transmitted to Earth for processing and storage. Since we are based on standard software, companies will be able to leverage IT expertise immediately without having to retrain their teams, saving time and money. Rick, can you share how we approach the development of the sat frame and maybe one use case?
We have a phased development approach. First, the TAC frame, which is a sealed, ruggedized, hardened, and air-cooled battery-powered solution. It'll be used on Earth in harsh environments for resource extraction and for DoD applications such as Air Force data payload distribution. It'll leverage hardline, satellite, and/or 5G communications. Currently, we're simulating TAC frame operations with a pair of HPE EL8000s. Second will be the C-frame, a liquid-cooled, waterproof, and submersible solution to be used on oil rigs and DoD applications involving saltwater deployment. Currently, we've been running a server submerged in our special oil solution for almost a year. After Phase 2, we'll have reached 60% of the requirements for space. And finally, we have the sat frame, which is radiation protected and designed to operate in low Earth orbit and beyond. We're sending 2 pilot sat frames in 2021-22 to verify full mission operations, and then we'll launch a 30-unit constellation into low Earth orbit. In Phase 1 and 2, our frames will be deployed by mining companies, oil companies, and sea transportation. These environments provide somewhat similar challenges to the Moon or Mars and make for a great proving ground. NASA uses the same approach to test technologies that are going to space. This phased approach allows Orbit's Edge to validate frame attributes before launch, develop customer relationships and requirements, and gain immediate revenue streams.
Partnerships are key to the Orbit's Edge strategy. We have signed an OEM agreement with Hewlett-Packard Enterprise to use their Edgeline EL8000s in our satellites, as well as partnerships with Red Hat Software for our software stack to include Red Hat Linux, Kubernetes containers, and IBM Cloud for connectivity.
Hi Sylvia, as IBM's distinguished engineer and CTO for Space Tech, One of my responsibilities is to relentlessly innovate and push the limits of technology. Edge computing is an important part of IBM's hybrid cloud vision, and I believe the edge computing will extend from cloud data centers to terrestrial edge to the lower Earth orbit, providing faster, actionable insights for the data being produced in space.
We also are a beta tester for IBM Cloud Satellite. I would like to introduce you to Joe Vidal of Hewlett Packard Enterprise, who is an OEM champion for our partnership.
Thank you, Sylvia. One of my responsibilities as a chief technologist for the North America channel at Hewlett Packard Enterprise, also known as HPE, is to constantly seek out new and exciting technologies that can be added to our own hardware and software-based solutions. What we found is that Orbit's Edge is a natural extension of HPE's commitment to space. The Orbit's Edge OEM partnership takes our spaceborne supercomputer initiative to a whole nother level after successfully running our HPE systems on the International Space Station for over a year. The HPE EL8000s will provide the performance and the security needed for space and other non-traditional outside the data center initiatives, or in this particular case, bringing high-performance computing and analytics as a service above the cloud, or clouds as the case may be.
Thank you, Joe. We are also in conversations with many other companies, including NVIDIA, Verizon, Bentley. Could you share our team and sales strategy?
We are a combination of aerospace and IT company, which is reflected by a diverse and seasoned team, which includes extensive Fortune 50, startup, and military experience. Sylvia and I have worked together for many years at Apple. I have extensive background in sales and plan to lead the direct sales team for large opportunities and will build a channel organization. A reseller channel will be extremely valuable for both ground-based solution sales as well as remarketing our infrastructure as a service solution above the clouds. In the space market, we have initially targeted organizations that heavily rely on Earth observation for time-sensitive decision-making, and pharmaceutical and healthcare organizations that will leverage microgravity for chemical composition. We have been approached by the Department of Defense, specifically the Navy and Air Force, for sea and ground-based solutions, and oil and gas companies to develop a solution for extreme harsh environments on Earth. Other opportunities include mining, utilities, and shipping transportation. All of these opportunities provide a unique, high-dollar niche market and an excellent proving ground for space.
Orbit's Edge has multiple revenue streams, including sponsorships and partnerships through direct investment by organizations, sales of TAC-frame, C-frame for harsh environments on Earth, subscription fees for access to the SAT-frame infrastructure in orbit, and sales of dedicated resources in orbit, which is virtual CPU processing time. Sales of storage in orbit, which is potentially terabytes. As you can see in the chart, our sales of the TAC-frame and C-frame will reach 3 million by 2022 and will help organically fund our development of our space mission. Without SAT-frame expenditures, we would break even in 2022. After the launch in 2021 of our first SAT-frames, we'll produce 2.3 million in the second year. Once we have our SAT-frame constellation of 30 satellites in orbit, we expect revenues based on space processing at the edge to reach 365 million in the fifth year.
As of today, there are no direct competitors placing multi-access edge computing in orbit, although we have seen hybrids that consolidate communications and in some cases analyze data in space. In the future, we expect Amazon and Microsoft will have cloud offerings in space, but it is unlikely they will focus on the edge solutions. Right now, they are focused on ground stations for communications. We believe our first to launch status will give us a huge advantage. Our intellectual property is a combination of patents to be filed and trade secrets for power, cooling, heat dissipation, security, and radiation protection.
Orbit's Edge is a unique platform that solves big, obvious problems on Earth and in space. We are tackling a very large total addressable market, which is already huge and growing, have a unique approach to protect state-of-the-art technology from harsh environments, developing proprietary technology currently being validated in our labs on the space coast of Florida. We have a compelling value proposition for our customers. We have a strong partnerships with leaders in space, computing, and enterprise software. We have a hybrid revenue model with Earth solutions to validate before space launch. We have experienced and diverse senior level management team, have been recognized as an innovator by NASA, the Navy, and many publications such as TechCrunch and Network World. This is an exciting market opportunity and hope you will want to join us in our quest. Thank you for consideration and the time today.
All right, thank you. Let's go ahead and get to questions. Harry, is that you?
Yep. So I guess one of the questions is going to come up is your radiation protection for space electronics. Can you say something about how you do it, or say something about how you tested to show that you can protect?
Muted, Sylvia.
You're muted, Sylvia, so I'll just step in.
Okay.
Our radiation protection system is it's a proprietary system, so I don't really want to get into too many details today on the public forum. We can talk about it a little more tomorrow. But it's designed, it's a fairly traditional approach to it. It's a thick, heavy material designed to stop 400 MeV particles. And it actually also produces a little bit of additional cooling capability for us. It's a unique combination of the two.
And so you have tested it in some.
We've done some initial testing with it. We've still got to take it into a vacuum environment and prove that out. And our first satellite launch is due hopefully at the end of 2021. And we're going to take it up into space and prove it out there.
Okay, so one of your premises is that you the data in space. Do you have customers who are willing to do that? Most of the people that I've talked to, the science folks, even though they want all the data back eventually anyway, and I know that slowly switching that people are going to start doing this, but do you have customers ready for that now?
The answer is no. What we've been doing is where we are in our development is we've been focusing on partnerships. So as we mentioned in the video that we have a very strong partnership with Hewlett Packard Enterprise. And we also have been working with others such as IBM and NVIDIA. Red Hat. So what we're doing is we're leveraging their expertise. And actually what's kind of ironic is they are looking at their customers and their customers are actually coming back to us for our solution, especially in the harsh environment sector.
All right, Rich.
There we go. Thanks, Rob. I have so many questions. I don't want to take up the whole afternoon. 15 kilowatt power satellite with cooling, that's a big bird. I presume you're going to be running it at a kind of a medium Earth orbit altitude. That kind of bird, though, is going to cost a lot of money, and you're talking about putting up a small constellation. How are you going to get there? I mean, I know you said you got your first one that you want to put in orbit next year. That's a big hill to climb. Can you provide a little bit more detail on that?
From a tech, Ross, you want to take that from a technology standpoint? Because our first launches are going to be with our Sat Frame 1 and 2, which are a smaller version of our constellation that we're going to eventually send up. So we know that we're going to have to scale eventually, but we also know that we're going to start small with 2 satellites for both Sat-1 and Sat-2, and then grow in the further constellations once we have the additional learnings.
Over my shoulder, you can actually see one of the EL8000s that we've got as a development unit. This one isn't going to fly, but we're going to fly 2 of these on our first 2 missions on each of our satellites, and we're going to fly a pair of satellites on each mission so that they can test out the communication capability satellite to satellite. These are going to end up being around about 100 kilos apiece for our first satellite, and they're only going to use about 1,000 watts. So these will prototype our systems in 2021, a repeat mission in 2022, which we will use with whatever we learn from the first mission. And then we will scale up to the full-size missions. And those are big birds, as you say. We're hoping to get between 5 and 10 on a Falcon 9 or perhaps even a Falcon Heavy. We may require the larger vehicle.
Thank you. And one other question: do you have you moved forward with your spectrum allocation? Do you have your licenses from IT or FCC?
We've begun the process, but it's going to take a long time. As we understand it, it's going to take about 18 months to be able to get our full allocations. We should have our S and X allocations ready for the first launch, and the others will come online, but obviously we won't be able to utilize the systems until we have permission to do so. It is possible we may be able to piggyback off somebody else's communications capabilities, like, for example, we may be able to test with TDRS ahead of formally getting our own allocations.
All right, John, you had a question?
Yeah, hey, all, John Carr here. So you started to hint at the end with your S and X antenna arrays, the power you plan and the schemes you plan on using. At what ranges do you think this is going to be useful for edge computing? How far away can my satellite be and still gain the benefits that you're offering?
Shall I dive in again?
Yes, please.
We're initially planning to put these into a 600 kilometer approximately orbit around LEO for the first 30 satellites. But we actually have a plan that we are in the process of putting together an unsolicited proposal to NASA to send 5 of these to lunar orbit in support of the Artemis program. So having 15,000 processors and many petabytes of storage in local communication to assets on the lunar surface could be very useful.
All right, Peter?
So I'm still trying to understand what your business model is going to be terrestrially or here on Earth. Who are the target customers? How are you going to, and second thing is kind of what Richard was getting at, how are you going to capitalize this huge expense of this network? So those two are just such big problems.
Bentley, why don't you talk about that?
Well, I mean, there's a vast number of customers that we've started to talk to. And just the other day, I was on the phone with companies like Halliburton and of course I've been doing a lot of work in the oil and gas world, so I've also been speaking with them. And as Sylvia mentioned, IBM and us have been defining a series of their top 75 customers that they want to approach for this solution. As far as capitalization is concerned, from an obvious launch place, obviously we need a VC capitalization, but as far as our revenue plan is a combination of licensing fees, raw processing, very big market for storage in space where there isn't anything right now to fill that gap, as well as backhaul, but obviously taking the raw data and boiling it down into some level of intelligence before it's transmitted back to a local cloud. We're not trying to be the cloud in space. We're trying to be a consolidator, an edge solution that collects data, that can process it, and then send it down for the final processing in the cloud marketplace. Very much like what's happening right now. And the reason I used Halliburton as an example is just on Monday, I was on the phone with them when we were talking about the edge solutions that they're placing out at their remote wells. Actually, Phillips 66 was on the line with me. And it was a great conversation because we're talking about the problems with communications at remote locations. It's very, very difficult to drop any kind of fiber or anything in the line. That the fact that, and I saw that Sunil called out in one of the other pitches of sawing the windmill tearing up. These kinds of things happen all the time. And what they were saying is, by placing the system at the edge, yes, they improved their ability to either shut down or evaluate situations ahead of time. But what they didn't expect was all the new things that they could do in these remote locations and the lack that they don't have to have as much communication. Today, everything is kind of dependent upon communications, right? And you need a high bandwidth. Well, when you don't have it, you want to try to put the processing closer. And so the idea is that in our case, we're going to place that processing and that storage right there where it's needed. Okay, and then only transmit down, or maybe not transmit down. Maybe an AI solution actually will respond. We have a full set of financials of how we expect that to go that actually we did work through with one of our cloud partners. And it's quite detailed. If you want to see it sometime in the future, it's something that we might be open to discussing with you.
Thank you.
There's a lot of opportunity.
All
What's
right. All right, Paul, and then Cheryl.
Thanks, Sylvia and Bentley. Nice job. Big market demand and need.
Yes.
You earlier described that your first step was to form partnerships.
Yes.
Can you describe to us the categories and types of partners by function that you decided to approach, and therefore what you need from each of those categories to build out your model, your business model?
Yes. So, for example, we specifically went to Hewlett Packard Enterprise for hardware because of their experience they've already had on the ISS with their spaceborne computing. And what's really been great about that partnership is that they've actually shared their insights. So that's helped to speed up our development. Then we went to partners like IBM and for our software stack. And then also it was a natural going to talk to people like Red Hat as well. And we were actually approached by Verizon with some of the conversations that they've had with some of their DoD partners about working with Zero Trust. So right now we've been going for partners for specific expertise and specific need has been our strategy so far.
Hey, can I just clarify something? It
Sure.
sounds like, Sylvia, that you've described a hardware partner and a software partner and kind of a
Correct.
system operator partner.
Yes.
Where then is your company's value added, and what form potentially a platform company would it be?
Bentley, do you want to take that?
Yeah, I'm not sure I totally understand the question.
Yeah, that's where, to understand the question. What do you mean by a platform partner?
So let me change it to, so you approach one for hardware, software, systems operations.
Yes.
Therefore, what is the value added? Are you the integrator? Is that really what your company is the value added to come to market, the integrator?
I guess you could say that. There's different requirements. Like, because we're not a massive data center, right? We're not IBM or we're not AWS or one of the big data centers. We can only take so much data at a certain point. There will be different analytics platforms, as an example, different AI platforms that we're going to run on that solution. But our plan is to provide basically the hardware platform with the base level of an open standard, and that's critical because we want companies to be able to actually leverage their IT resource, and then be able to go to a cloud partner to buy that. So, in part of our sales strategy is to leverage partners in these areas, and then let the customer choose some of these base solutions. I think that's what you're asking as far as the platform. So yes. we are basically be like it's not like a fair claim, but we're like the colo center with all the SaaS software already loaded, but it's flying around in space.
Got it.
Yeah.
Right. Thank you.
All right, last question, Cheryl.
So if capital wasn't an issue at all, what else would your constellation of satellites have, from a feature or hardware perspective?
You're talking about processing. I mean, the whole idea
of processing, storage, bandwidth, anything. If it wasn't a cost function, would make a better product in your plan. But right now, it's not affordable.
Ross, why don't you take that?
Sure. I think probably the number one thing that we would like is more satellites. We're going to start out with 30, which gives us basic global coverage, but we want to add another 60 within 18 to 24 months. So it's about capacity at the end of the day.
Thank you.
All right. Thank you very much. Max, back to you.
Thank you, Orbit's Edge. We are going to move on now to Corey Lynn with LVX Systems.
Hello and welcome to LVX System and the LVX System of Companies. My name is Corey Lynn, CEO of LVX System. Imagine for a moment a building, say a school, with a network of lights that not only illuminate, but communicate with each other and the devices within the room through a wireless signal that uses the same photons to illuminate free space. The light fixtures have edge computing power. The network is equipped with cameras, speakers, and microphones. And this same network is also integrated with the physical premise security system. This network disables certain features on phones like cameras or microphones in areas they are not to be used like bathrooms, locker rooms, or during classroom sessions, all performed wirelessly and safely. Imagine further, wearable glasses with built-in speakers and microphones, wirelessly connected to the lights in the ceiling that are providing, through visible light communication, the necessary data throughput to have all the students in that classroom and the classroom next to it, and all of the classrooms in that school building have a 3D experience in real space of anywhere in the world, or even in space. Imagine these wearable glasses can replace the need for your telephone, television, computer, and even stereo system. This is the future of the LVX system of company. Again, my name is Corey Lynn, CEO of LVX System, the parent company of the LVX system of companies. And that imagination will be possible with the now commercialized LVX Li-Fi platform. Few people in the world could have imagined something as I just described, but our founder, Felicity John Peterson, did many years ago and has been awarded 55 patents to ensure LVX would be able to participate in the creation of a whole new ecosystem of wireless communication through visible light. Bidirectional visible light communication, also known as light fidelity or Li-Fi, was invented and patented in the United States by Felicity John Peterson. Our LVX lights use LEDs that modulate faster than the unaided human eye can detect. Thus, with the same photons used for lighting a given space, the LVX Li-Fi platform provides a physically safe, highly secure, wireless communication option to send and receive data. Let's take a moment and revisit a time when two astronauts graced us with their presence to launch the LVX Li-Fi platform at our corporate headquarters at the Astronaut Memorial Foundation located at Kennedy Space Center.
Welcome to NASA here at our offices where we are beginning the illumination ceremony for the lights here in the ceiling, LVX service. And joining us today is Colonel Lausma.
Glad to join you, John.
Good to have you, Jack, here. Yes, I appreciate you guys coming. John McBride. Good to meet you too. Two astronauts from NASA going to push the button and launch this service.
Number two.
Number two. Should we have a countdown?
3, 2, 1.
Now, with 55 awarded patents, all irrevocably licensed to LVX system and pertaining to the Li-Fi technology, the business model, and the use of Li-Fi with services and features like bidirectional communication in free space, device enabling and disabling, human inventory capturing, facial recognition door strikes, GPS routing systems, and Li-Fi enabled wearable glasses, just to name a few. We are ready to, at no upfront capital cost to the customer, install a new lighting experience and a freestanding network we call the LVX Li-Fi platform. To be clear, our patent portfolio is not intended to prevent others from developing or participating with LVX in the new Li-Fi ecosystem. Rather, our patents are to protect our entry and our participation in the developed and yet to be developed markets our utility-like service offering and the Li-Fi platform can and will integrate with. Our utility-like service model nearly eliminates all future maintenance and future costs for upgrades of the lighting experience through the length of the contract. The LVX Li-Fi platform also provides a new ecosystem for developers, engineers, technicians, and future visionaries to bring to market enhanced cyber and premise security services and features. This same ecosystem will exponentially enhance the bandwidth of wireless connectivity. According to Cable Labs, the difference between Wi-Fi throughput and Li-Fi throughput is comparable to the difference in mass of the Earth for Wi-Fi throughput to the Sun for Li-Fi throughput, potentially enhancing beyond current comprehension the virtual training and gaming experience of the future. LVX aspires to be the rebirth of the Bell system with new technology. LVX thus had to solve the riddle of how to roll out an infrastructure such as our LVX Li-Fi platform with such established giants of product sellers in the lighting industry like Philips, GE Lighting, a Savant company, Cree, and Panasonic, where the total market size of these entities is slightly under $40 billion in the United States annually. And let's not forget about the American-based telecommunication and wireless Goliaths like AT&T, Verizon, Charter, Comcast, T-Mobile, and CenturyLink. These 6 companies alone combine for nearly $500 billion in annual revenue. There's no doubt we'll be susceptible during our period of growth, but we feel ready to enter the battle, find our strategic partners in both lighting and telecommunications, and compete for market share in lighting and soon into telecommunications too. And that's because our business model allows us to build out the networking platforms at no capital cost to the customer. It's free lighting installs with immediate operating cost savings over fluorescent lights, while our patents and our Li-Fi platform will allow us to develop and/or license new increased revenue sources through the use of our networks by our customers and our strategic partners. It is a unique approach to building a network across the entire country. Unlike cell phone towers that require telecommunication usage to generate revenue, for example, our network platform, through the installation of a free lighting enhancement, generates revenue, thus paying for itself, regardless of telecommunication services being utilized by our customers. Upon activation of the LVX Li-Fi platform, LVX will have access to cash today from contractually obligated recurring revenue streams through the use of lockbox financing with our established banking partners. Let's take a moment to hear from one of our customers.
We haven't had any issues with the lights that we've used, or the lights from the data or from the light itself. We've been very reliable and have not had an issue at all.
By applying lockbox financing in the early stages of our commercialization launch in Florida and Minnesota, LVX can be cash flow positive through the installation of 5.5 to 6 million illuminated square feet, which can be attained in 2021. For reference, in just one of our initial target markets of public K-12 school districts, Florida has over 425 million square feet, and Minnesota has over 125 million square feet. That's over 550 million square feet of K-12 public school district buildings, and LVX would need less than 1% of that to cash flow positive. The percentage of market share needed to be cash flow positive just in the states of Florida and Minnesota becomes even smaller when you add our other ideal customers like private K-12 schools, colleges and universities, cities, counties, healthcare facilities, government agencies, and the armed forces. We believe that by reducing their energy usage, providing a better lighting experience to their students, staff, and visitors, and saving them money without having to spend any money up front, we too are ideal for them. At a national level, U.S. government data shows there is over 88 billion square feet of commercial buildings across the country. To cash flow positive, LVX needs less than 0.007 of 1% of the nation's illuminated square footage. Current projections show at 2% of the total national market, LVX will generate over $500 million in annual revenue. The amount of operating capital projected to attain a cash flow positive state of the business is less than $15 million, which we are actively working to raise. Why is this important? Simply, if LVX System is not able to sustain being a viable commercial entity, our passion and desire for continued engagements with NASA, the federal government, and the armed forces of the United States of America, along with law enforcement, cannot sustain either. Having already completed successfully a Space Act agreement with NASA, as well as issuing a master license for visible light communication with the U.S. government that has led to multiple patents ready to be filed, we feel ready to repeat that objective as we go forward. Through the use of our mock orbital shuttle Inspiration, currently parked near the control tower of the shuttle landing facility at Kennedy Space Center, LVX System will develop the Inspiration Lab for continued research, engineering, and development of aerospace utilization of the LVX Li-Fi platform. For example, the LVX Li-Fi platform would not likely be a standalone communication system during space travel, but as a redundant sidecar wireless communication system that can reduce the weight of the vehicle at liftoff by using broadband over power line, while also eliminating the harmful radiation that comes from radio frequency waves that are exacerbating the elements of space, all while providing our astronauts a healthy lighting experience during their travel. It would appear to be a viable choice for consideration as that redundant communication system and primary lighting source for human space travel. Space, of course, is not just about what goes up and what occurs when it gets into space. There's also the ancillary ground services the LVX Li-Fi platform can integrate with. NASA and private enterprise buildings could also utilize the LVX Li-Fi platform for primary lighting and as a redundant, secure, wireless communication system. The platform, utilizing Li-Fi with cameras and through the use of edge computing, will be able to track high-value equipment, tooling, and personnel. The requirement of no radio frequency waves will no longer prevent the presence of a wireless communication system in sensitive or secure locations when the LVX Li-Fi platform is considered. The team at LVX System has evolved over the course of 10 years. Today, as we transition from an R&D phase into a focused commercialization launch, it may surprise some that we currently no longer have any PhDs on staff. At this time, LVX contracts the electrical and mechanical engineering needed to put our proven technology into new form factors for commercial use. The LVX team does have decades of experience in telecommunications, energy, security, and aerospace, yet we are still at the ground floor for engagement opportunities within our business operations. Areas of finance, sales, network engineering, software, and product development have significant growth opportunities at LVX System today. The R&D to commercialize is complete. Now the business must launch. Along with our founder, who's been a pioneer of LED development and application, and relationships established and yet to be established with federal agencies, the armed forces, colleges and universities, and private partners, the further development of Li-Fi will be driven by LVX, our customers' needs, and our founder's visionary mind. At LVX System, we believe we have the potential for billions of dollars in recurring revenue as we deploy, again at no capital cost to customers, a new wireless communication platform. As we do the continued collaborative development with agencies like NASA, the Armed Forces of the United States, and the federal agencies of the United States government, will continue to enhance the applications in space, aviation, cybersecurity, and premise security. Thank you for your time and consideration of the LVX system of companies and the LVX Li-Fi platform.
All right, let's get into questions. Peter, we'll start with you. Okay. There we go.
I'm just trying to understand the unique new applications for the agency. I mean, you already have a partnership with Kennedy, and I could see those examples where you currently have rolled out this capability, but where are the kind of unique areas that are pushing the edge or that's really novel to for your application?
That's a great question, Peter. Appreciate it. At this time, I would say that that would be something we'd want to work through with NASA to find out. I feel that building and premise security is one of those areas. Our Space Act agreement revolved around the use of cameras, speakers, and microphones with the human inventory tracking, with the ability to be able to keep tabs on where high-valued equipment materials, things of that nature, all while not needing to utilize Wi-Fi or even telecommunications in that standpoint. The fact that it is a network is one great opportunity that we see here, but are very open to learning more about how the NASA teams all across the country would be able to utilize the platform for their specific needs.
Okay. I mean, I could see eclectic niche areas possibly for robotic spacecraft or other things in other unique environments. But let's discuss it at the impact table.
I look forward to that. Thank you.
All right, Harry.
Very nice presentation. A couple of questions. First is, to connect my computer to or my mobile device to your system, do I need any special hardware or is it already configured?
That's a great question, Harry. I have in front of me what we refer to as our client key. This has a standard USB port that can be used for devices. Also, though not currently enabled, a standard smartphone does have the necessary features with the LED in the back and the camera. The software to be able to do that is able to be provided to manufacturers of cell phones by LVX. So again, with this particular client key that we have here, which we are working to re-engineer into further form factors, that would be the means by which we would establish connectivity with devices.
Okay, the next question comes up is security. How do you address security? Is it different than how you do Wi-Fi, or people can intercept the light easier than they can Wi-Fi?
That's a very interesting way to look at it, and I appreciate that, Harry. I have behind me, right above me, one of our form factors. It is a 2x2 fixture. For someone to be able to steal the signal that would be communicating down from that, they would have to physically walk in and be present to me to be able to capture that signal. They would have to physically place a device to be able to capture that underneath that. Now, with my camera and my physical presence here and all the people watching with me, I'm pretty sure we would be able to detect that someone was doing that. The light also does stay within the room. And so it does not transmit outside of obviously physical space. So we feel very comfortable that although anything is possible, of course, when it comes to individuals trying to do harmful and dangerous activities with our security, that we offer a platform that is able to enhance, if not come close to eliminate, any types of cybersecurity concerns.
Does it only work with visible light, or can it be different frequencies? So, for instance, if you're reading at night and you don't have your lights on, you lose your internet connection?
Another great question, Harry. Thank you so much. We are able to dim the lights lower than the human eye would be able to detect while still sustaining a connection with our wireless communication.
Very much.
Thank you.
All right, Ramona, let's go to you.
Yes, I heard mention of the fluorescent lights that are used. Is that an actual limitation, or is it any sort of light, especially LEDs, which are so common these days?
Great question, Ramona, and thank you for the opportunity to clarify. Right now, the low-hanging fruit for us is to be a replacement for fluorescents that are still being used. Though we have a competitive proposal for customers who currently are using LEDs, we are not targeting them initially out of the gates. We are instead looking to find areas within our ideal target base that are using fluorescents and being a part of their transition from fluorescents over to LEDs. Our communication only uses light-emitting diodes for providing the wireless service.
Okay. Connected to that, I'm still trying to understand some of this technology. I did see where the physical range could be beyond just vis into UV and IR. That was not the impression I got from this presentation, but that's something I've read. So how far, I think Harry asked about the range, can it go beyond visible?
Yes, we are actively working on getting not only to the UV, but to far UVC for some of the safety and health of benefits that can provide. The technology from visible light communication, as well as the full range of the spectrum, I would have to defer to our engineering team to be able to further get into that, which we may be able to do tomorrow during the further dive questioning.
Okay, and one last question. I understand that other sources of light may interfere with the signal, so how have you dealt with that? Even, I guess, sunlight coming in through the window. How does that interfere with things?
Yes, that is a very fair question. We see no interference or diminishing of our signal from sunlight. As an example, the modulation is able to be detected. It does kind of, the analogy that I've been told that I like the most is it's kind of like listening to a person talk in a room of screaming individuals, but it is attainable, and it has been proven to work both internally within a building and also externally. We don't talk about this in our presentation. We do have patents, though, that protect us for when we go outside of buildings into outdoor space.
Thank you. I'll let others ask questions.
Thank you, Ramona.
Great. Let's go to Sherman.
Yes. How are you doing? Two questions. So do you need a clear line of sight between, let's say, that smartphone device that you just showed and the device up in the light fixture? Almost like you would a remote with a TV, remote control with a TV? Another great question, Sherman. Thank you. We would prefer that. Okay, we would prefer that, but we have been able to bounce our signal around a corner to be able to sustain streaming 2 separate movies off of the internet. There is some reflective qualities, which again opens up a Pandora's box as to the material that it would be reflecting off of as far as the signal strength that would be able to occur. Now, what we are also able to do is assist people in understanding that lights don't always, of course, need to be in the ceiling. Right, and so that could be another opportunity for us to get source for the signal to be transmitted. Got it. And then the second question is a standard regular individual able to install your device with the light, or do you all have to install yourselves? No, that's one of the beautiful things that we've done here is we're looking to partner with both union and non-union electrical contractors. This is a very simple installation. Our 2x4 fixture, for example, is very similar to a retrofit. Replace the established ballast with an LVX driver, install our lights. Fixture installation is very similar as well. This is very entry-level work for established electrical contractors. It's one of our very significant stakeholders that we see as we go to market across the country. Got it. Thank you.
All right, Cheryl.
So I have some experience in real estate tech, and the mantra we've always said is never ever sell to K-12 in the United States. And so I'm curious why, you're laughing. So why did you pick K-12, and why wouldn't you instead just go for commercial real estate, landlords, which love to save $1 more than anyone else in the entire world?
It's a great question, and I kind of smirk because of the battle scars from the attempt to do so. The reason is because the lockbox financing is so important to us to not fully need to be dependent upon equity sale for commercializing this project. We're after high credit rating, and schools. They pay their bills. Cities, they pay their bills. So we understand that it is a much bigger fight than going into tenant-occupied space and being able to reduce the operating costs on a per square foot basis. But we feel that it's worth going after because of the fact that it is so important to how we are going to finance the rollout of this infrastructural apparatus across the country.
Does that mean that your margins are low? Because usually a higher number of clients with poor credit's fine if you have lower margins. What do those look like?
Our entry level margins are low. It is pretty much break even, 4 to 7 year rate of return on the investment that we make, depending upon our most significant driver of cost of service is going to be a kilowatt. And so that's where the free install is based on a land grab. Okay, that we want a land grab. The margins come when we start bundling services and features on top of that. The infrastructure, the capitalized assets will already be in the building. Thus, the addition of services and features have very high margins. And as we go forward and look to lower our kilowatt hour rate, whether through partnerships with power companies and providers or through the installation of renewable energy installations on site, any reduction in kilowatt hour cost to LVX is pretty straight down to the bottom line.
Thank you.
Any other questions?
Yeah, let me ask a question. Wi-Fi is pretty easy to install. And so you're really competing with people who want to install Wi-Fi. And at least during COVID, my rate limiting transmission step is the internet provider coming into my house, not the Wi-Fi within the house. How does this compare? So what does that say for your business plan? How do you address that?
Well, it's a great question. We do not see ourselves as a competitor of Wi-Fi. We see ourselves as complementary. We see ourselves as an additional option, which is why we have to make the business model make sense based on being a primary lighting source before we get into being solely dependent upon visible light communication. The other thing that we look to do is to identify that, again, because every single light fixture, every single LVX light becomes a data point, we are able to replicate our speeds over and over and over again. So again, when we talk about the redefinition of speed, it's going to be exactly what you talked about, Harry. It's going to be about the speed coming into the building, not necessarily the speed coming out of an individual light.
All right, anyone else? We have time for a couple more.
There was a question about, I'm sorry.
Go ahead, Max.
I was going to say there was a question about interference from sunlight. I'm just curious, and this is just ignorance on my part. If there's you presumably got lots and lots of these lights in an individual space. Do they interfere with each other?
That is a great question. At this time, no, they do not interfere with each other. Each of our lights ends up being its own individual IP because they are CNC controlled, and so the device is able to know which one it's connected to, which ones it's talking to. Great question. And again, another analogy I'd like to just quickly share is if we were to take a candle and we were to hold it outside even during the day, we can still see the candle. I apologize, that may be another simple way to understand how this can work also outside. Richard, I saw your hand was up if there's still time.
Yeah, Richard?
Yeah, I'll jump in if he's not ready.
What's the actual range of the device? I mean, how far away can you pick up this signal? We talked about frequency, but how far away could I get and still get a signal?
Yes, that's a great question, and that's going to come down very much so to the form factor that we are utilizing. And so with a high-powered flashlight, for example, we've been able to attain very long speeds. City blocks have been able to be attained as we look to keep a focus on eventually getting outside of buildings as well. So it's very dependent upon it's very dependent, again, upon the form factor. Inside of a building, we don't obviously pursue that. When we go outside, we recognize that we're going to want to get to city blocks, and then we're going to want to get to miles. And eventually we'll want to integrate into even over-the-horizon type communications through visible light communication.
Roger that.
All right. Thank you so much.
Peter, so Corey, I was intrigued by in your examples in the video that there were like these transducers or whatever you're calling them every like 5 or 6 square meters. It seemed like a lot more than I would envision. How many do you optimally need, and how many can you get by with as few as possible?
That's absolutely a wonderful question. That was a form factor that we have developed and taken out into our beta sites. We're able to get by with, for example, 1 or 2 in a room, depending on where the occupant wants them to be located. So in that visual that you saw, and the visual you see behind me, the receiver, which is also, again, just this part right here, that's built into every single form factor. We've since pivoted to now where that's outside of the form factor. And so we're able to place those wherever our specific clients need, thus providing them also the flexibility because, as we know, people sometimes like to change where their desk is.
Got it. Perfect. Thank you, sir.
You're welcome.
All right. Thank you so much. Max, back to you.
Thanks, everyone.
Thank you, Corey. We're going to move on to Ram, and who's going to be presenting for Autonomic.
Good morning. My name is Ram Shanmugam. I'm one of the co-founders and CEO of Autonomic, and I want to thank the NASA team for giving us an opportunity to present our story to all of you. Our vision at Autonomic is to help developers and software engineers write beautiful, high-quality software. The volume and velocity of software is increasing exponentially. What does that mean? Previously, it used to take a couple of weeks to a couple of months to produce software. What has happened over the last few years is software is being released at the pace at which people are writing code. So if I'm writing code today, the expectation is that that product should come out the same day. So the time it takes to test and validate and verify software has shrunk dramatically. It used to take 3 to 4 weeks to build, test, and release software. Today, it's taking less than a day. In some cases, in a couple of hours, people have to test the code that they're writing and publish it to the real world. The other thing that has happened also is the complexity of software has increased tremendously. What does that mean? Here is an example of the volume of code that's being produced for various applications. On the green, you see the amount of code being written for just cars, and the blue on the top, you're seeing the amount of code that's being written for a complex application like the Mars Explorer. What this means is not only the volume of code and velocity of code has increased, it also means that the complexity of software has increased. So it puts a tremendous amount, and now if you combine the two, the complexity and volume and velocity, you suddenly find yourself in a situation that you just don't have enough time to test the quality of product before it goes out. How are people solving this problem today? So the first thing they do is they do manual testing. They have manual testers that walk in and essentially try to test code. It works, but again, at the speed and velocity with which things are changing, the manual testing approaches don't scale. The other approach they're using is to repurpose legacy testing tools. There are several open source and custom legacy testing tools that people have created over time. And the challenge with using legacy testing tools is they were not designed for this new world that we're in. They were designed for a world when we had a few months or a few years sometimes to release code. In the new world, the time to test and time to release code has shrunk dramatically, and therefore you're finding yourself with less and less time, and repurposing legacy tools doesn't really work. The last piece, a more common trend we are seeing more recently is, well, let's go build our own automation. Now, the challenge with that is, one, it's hard to find these consultants and experts to build automation. The second big challenge is, you are now shifting from your core focus to a focus on building tools for your business. An example, a big bank we were working with a couple of weeks ago, they had hired a team of 40 people to build automation for testing, and they still hadn't figured out how to solve the problem. Whereas, in our conversation, when we showed what we had built, they were quite impressed. Now, the challenge for them was, are they a bank? Are they a testing tool software company?
and obviously the answer was they want to be a bank and not be in the business of building automation. So the legacy approaches to testing software, I guess in summary, doesn't really work, because either you throw people at it, or you try to repurpose legacy tools, or try to build automation yourself. All of these are band-aids to the current problem. How big is this challenge? Sometimes we don't quite understand the magnitude of this problem unless you start seeing it in real numbers. In 2019 alone, over $1.7 trillion was lost in economic value due to software bugs and glitches. Here are some specific examples. NASA Mars Lander program lost about $125 million in R&D because of a software bug. The Ariane space program, for example, they lost their one of their key rocket ships, and the impact of that loss was about $8.5 billion. It's sometimes not just an economic value, it's also impacting in terms of brand. Facebook, for example, had a software glitch that exposed sensitive private data of over 7 million users. And the reputation and privacy impact of this loss was huge. It was, almost incalculable. So in summary, I think as software becomes more mainline and mainstream in our daily lives, software bugs and issues continue to wreak havoc in terms of how much economic value they cost to us and to the economy, and something needs to be done differently about it. So our mission in life is to build amazing products that reduce the quality issues and eliminate bugs in software using autonomous technologies. We have a brilliant team of scientists and advisors that have worked with us, continue to work with us in helping realize this vision. Besides myself, Ram, I have an eminent team of scientists and advisors from the best universities and the best industry experience. Jim Whitehead, who runs our science program, is a professor at UC Santa Cruz, and previously he had worked at Google and Microsoft. Raj, who's my co-founder, he came from CA Technologies and SAP, which are premier companies that have built tools and products to address quality issues. John Schaefer, one of our advisors, he is a preeminent AI machine learning expert based out of University of Alberta. Together, we built an amazing team of scientists and engineers to address this quality issue using AI and machine learning, which we'll talk about in a second. What do we do? So our core innovation allows our application to understand software that is being tested and generate automation, autonomous code to test the software. We today, using our application, can test various aspects of software quality, starting with functional testing, API testing, performance testing, compliance validation, and user acceptance. If you think about all the functions, all the validation, verification needs of software, we essentially cover 95% of all the functional and all the verification and validation needs for software quality. The only thing we don't address today using our product is unit testing, and we're working on the capability to address unit testing needs as well. How does your software work? Essentially, there are 4 components to our product architecturally. The first one is the ability to understand what application or software you're trying to test. We use a technique called behavior trees. Think of it like an agent that crawls through your application and code and essentially builds a graph of your entire application. The advantage of doing that is it understands when the application changes and the code changes, and automatically knows when to trigger testing when functionality changes. Then we use a variety of techniques like natural language processing, machine vision, grammar-based techniques, and GANs to understand the intent of the application. These techniques by themselves are very well-known techniques and nothing proprietary about the techniques. But what's unique about how we build the application is we have essentially taken all these techniques and trained and purpose configured these techniques to work for the software testing world. The ability to understand what your application is doing and generate test scenarios. The ability to visually inspect software code, just like a human tester would, and form understandings and come up with scenarios that can test is another unique capability of our machine vision capability. We use a lot of grammar-based techniques to generate test data. Synthetic test data is a key component of testing, and we use that GAN-based approaches and grammar-based approaches to do that. Together, combining these various techniques, we generate test scenarios, test automation code, and test data, and combine them and run them to identify bugs and issues. In addition to the capability of testing from one location, we've also built a network that allows us to test the experience of the application from different locations. Today, customers are using applications and software from various points in the world. Particularly with remote work, a lot of enterprises want to be able to test code from different locations. We've taken our technology that tests the quality and efficiency of software from one location and expanded that into a network. And the idea of doing this is to simulate remote users using your application and see how your software performs. This is another added advantage of our capability. Using our product today, customers have generated significant improvements. We've seen up to 80% reduction in time to test software. We've seen about 60% improvement in coverage of quality, and then double the productivity of a developer. Commercially speaking, our product has been in the market for about 2.5 years, 3 years. We have a free version, a developer version of the product that today is used by over 600,000 developers globally. We have some of the world's leading organizations using the free version of the product to test code. In addition, we have an enterprise version. Today, we have over 40 enterprises globally using the product. Some of the household names you see have been using our autonomous testing product for improving the quality and performance of their software code. We also today use our product. Our product is also used by several industry partners. Some of the partners that you see here on this slide use our product for their customers, and some of them use it internally for improving the capability of their internal testing organizations when they deliver services to their customers. We've also been recognized for a lot of the innovations that we have created over the last 3 years. One of the more important ones that we were recognized recently was by IEEE. IEEE has created a separate chapter for software testing, and one of our core papers on autonomous testing received the Best Paper Award for innovations in software testing. From a company perspective, we are a startup. We started the company in 2018. Over the last 3 years, we have consistently grown. We end the year with about 1.8 million in ARR. We are also looking to expand our autonomous capability to extend beyond testing into other use cases. We hope to achieve and demonstrate these use cases in the next 2 to 3 quarters, which extends beyond testing into capabilities like configuration management, patch management, etc. Our goal is to, as we continue to grow, to hit about 6.5, 7 million next year and continue the growth beyond that. From a funding perspective, we are venture-backed. We raised a small round of funding last year, and we're currently in the process of raising our next round of financing. Our goal is to raise 7 to 10 million in financing, and that will help us achieve the revenue goals for next year, as well as set the company up for growth in the following year, which we hope to hit about 19 to 20 million in revenue. Our funding will allow us to scale beyond product engineering to build out our sales and go-to-market team, as well as customer success and some of the technical support functions as well. Hope This was informative, and I once again want to thank NASA and the iTech team for giving us an opportunity to share our story. And we will look forward to answering any questions.
All right, thank you so much. Let's start off the questions. Harry?
Thank you again. Very, very nice. So, I mean, this would have, I mean, I understand the impact this would have. What I'm trying to get, what I don't really get a feel for is how easily it works and how well it works. And I'm hoping that when you go to the, that you're willing to show us a demo tomorrow at the tables. I really would like to understand how it.
Absolutely, yeah, yeah. No, we have a couple of 100,000 users around the world using the product today, and they use it pretty much daily to test applications ranging from simple web applications to complex mathematical applications or scientific applications. And we've heard nothing but great reviews. Our tech is rated 4.8 out of 5 on Google by over a couple 100,000 users. So it's pretty robust, and you'll be quite impressed. I will show you a demo tomorrow.
Very much.
So I'm intrigued by it too. It's got a lot of potential impact, as you well know, since you're in the field. What is the input of the that you input to this? Is it source code or is it the executable? And who's the user of this tool? Is it someone in your organization, or do you sell out this tool and a software development team would use it? And what type of skill base do they need?
Okay, so it's a software product. It runs on the cloud. It's a SaaS application. We also deploy it on premise. The input or what we need is the binary, the application itself, and the binary itself is good enough for us to test and validate. What we are building is a plugin that allows us to also input source code. And when you input source code, we can then tie failures to where it fails in the source code, and to be able to instrument that. That's the next level of evolution on the product. Eventually, we want to get to this ultimate vision of self-generating applications where we can heal the application itself, not just identifying the bug. So that's what we want to get to. So self-healing software, again, the idea is when you have remote applications, you just cannot go and fix it. So you just want to be able to self-heal as you go along. The user itself, I mean, it's designed for a developer, and I think I'm a developer. Raj, my co-founder, is a developer. We had to test code, and we used to hate testing code, right? So we felt like it needs something that a developer can use with a push of a button, and that's the user experience essentially. But in terms of how deep you want to go and how technical you want to go, there are different levels of user experience. But the idea here is you should just be able to, from a command line, initiate the testing, and it should work, and it should tell you what succeeded and what failed.
Great. Have a good discussion. Look forward.
So, how large a software can you do? Usually, these validation or verification software, they explode exponentially with the length of the code and the number of things in there. Can you really, if you get given a couple of million line or 5 million line piece of code, can you actually sit there and really comment on it?
Yeah, so I can give you, I don't know about pieces of code, but I can tell you the complexity of applications we've tested, or our customers have tested. We have our customers, I mean, we have, Amazon has tested our product on their primary code base, on their primary application. Oracle has tested it on their core application use cases. We've had users from Salesforce. So some of the more sort of robust, large, complex enterprise applications have been tested and validated against this application. Honeywell uses it on both IT and industrial applications for testing and validation. So it's been used in pretty complex and pretty mission critical environments. In terms of lines of code, I can't comment. I don't know how to quantify that at this point.
All right. Any other questions? Cheryl, let's go to you.
So I see you have several integrations, and one of them caught my eye because it's Selenium. How many products is your product dependent on in order to run its test case?
So all we need is the application that you're testing or the environment you're testing. So there's no dependency from that perspective. What it generates automation code at the end of the day, test automation code. We are not dependent on Selenium. One of the more common outputs is Selenium, which is an automation framework, and we generate Selenium code. But that happens to be the most accepted automation programming language, if you will, for automation coding. But our output could be anything. We could generate other types of automation code. In fact, some of our customers have taken it and used it for generating robotic process automation code, for example, not just test automation code. What we're doing is today, this work is done by testers and test automation engineers. We've essentially created a machine equivalent of a test automation engineer to generate the automation code and run tests. And Selenium happens to be one of the more common frameworks, but we do support other frameworks. In terms of integrations, it integrates into other DevOps and CI/CD tools, which is essentially how people use our product today. Sorry, Cheryl, go ahead.
So you're not running Selenium when you're doing your browser testing or anything like that. You guys built your own browser-based testing?
No, we do generate Selenium code and use that for testing. So our output is Selenium code or Selenium++, other things. Yes.
Thank you.
Rich, let's go to you. Rich?
Got me?
Yeah, we can hear you.
Yeah, I was going to ask a little bit what Harry said. Some of the code out there is very large, and some very sensitive users use very old software systems and mainframes. We're talking Fortran and stuff like that.
Yeah.
Where the data is very sensitive. Banks and things like this. How would your process be useful to those kind of coders? I asked the question because my son is very high up VP of a bank, a large credit card and bank company, so he might be very interested in.
Yeah, so it's a very common request. Our customers use it. So we have a cloud version, but we also deploy it on premise for private instances. So we do have some large banks that take our product and deploy it on their internal data center for testing. So that's how we overcome the security and other concerns customers may have. But another sort of data point I just want you to be aware of is our application from types of code base and types of applications we test. We don't work with old legacy client server or green screen type applications. So our system doesn't work with that. It has to be browser based, mobile based, or API or cloud-based applications. So some of the mainframe applications we may not be able to support or test currently.
All right. Paul, you had a question?
Hi, Ram. Thanks a lot. I don't have a technical background, so I'll ask a business question. You actually just answered the first part of it when you answered Rich, which is how far back it goes in legacy systems. So my short follow-up from that is, during the development, did you find cases where your product was not able to complete the testing objective, and therefore you learned from it and then you improved it? And if so, can you just give us one example of that?
Yeah, so one of the things, so when we first developed the product, we did not have test data generation as a capability in the product. So as we were testing, our customers would ask for synthetic test data. So when you test, to test applications, you need data sets, and they don't want to use production data sets. So we would manually generate those data sets for them or the customers would have to generate their own data sets to test these applications. So a year later, as the product evolved, we felt that we could use some interesting AI techniques to essentially understand what data sets are needed. And we synthetically now generate data sets for our customers. So that's an example of how we were customer driven. In fact, we're taking that test data generation to a completely different level, where we're coming up with this notion of a synthetic enterprise. So let's say you're a bank, or you're a retailer, or you're a manufacturing company, and you want to test all your applications. In order for you to test, you need a large volume of test data that mimics your or simulates your entire enterprise. So what we are building currently is the notion of a synthetic enterprise where if you're a retailer, we will have all the data sets you need synthetically generated by our AI system to be able to automatically test and validate your applications in a retail environment. So you don't have to go looking for synthetic test data sets.
Great answer. Can I do one quick follow-up then? Is it fair to interpret, or have you therefore formed vertical markets or specialty user groups that are giving you feedback by vertical market and functional need so you evolve the capabilities? Am I hearing you right?
Absolutely, yes. Absolutely,
okay.
Yeah.
All right. Do we have any other questions?
I have one. When you make version 2 of this software, do you use version 1 to test version 2 and make sure you haven't messed anything up?
Yeah, we use our product on our own product. We have autonomy. Yes, absolutely. That's one of our success criteria before we release the product. Absolutely, yes.
So how long until you put yourselves out of work when you do that? Once it starts just writing itself, then you're out of a job, right?
That's right.
Were there any other questions from the panel before we close out? Okay.
Thank you.
Well, thank you, Ram. Really appreciate it. First of all, I'd like to thank all of our finalists and our judges for doing an amazing job. I'd also like to thank all the people that tuned in and watched on the live stream. Thank you. We hope that you enjoyed the program today, and we hope you can join us again tomorrow at 4:00 Eastern Time. Our keynote address is going to be given by NASA Chief Technologist Douglas Terrier, and at the conclusion of that discussion, we will announce the Cycle 2 winners. Thank you all for joining us, and thanks to all our participants today.
Thank you.